stand up. Right now, without thinking about it, you're balancing your entire body weight over 2 small feet, using something like 200 muscles just to keep from tipping face first onto the ground. You do this so automatically that you've forgotten it's basically a magic trick your body performs every single second you're awake, walking to the fridge at 2 a.m. without even turning on the light. No other animal on the planet does this the way you do, and that difference almost didn't happen at all. If one specific evolutionary gamble had gone the other way, you wouldn't be standing here reading this. You'd still be built like every other ape on Earth, knuckle walking through a forest somewhere, using your arms as often as your legs, your spine arranged completely differently than it is right now. So what actually happened? And why did it take science until the last few months to finally start figuring out the real answer? Most people learned some version of the same story in school. Our ancestors stood up so they could carry tools, use their hands, see over tall grass on the savanna. Walking upright, the story goes, was the smart trade our ancestors made once the environment demanded it. It sounds clean. It sounds like evolution had a plan, checking off boxes in a logical order. Brains, then tools, then walking to go use them properly. It's probably backwards. For decades, researchers argued over which came first, brains or bodies, tools or posture. And the fossil record was simply too thin and too fragmentary to settle the question either way. Textbooks kept printing the tidy version anyway, because a tidy version is easier to teach than an open question. In January of 2026, that changed. Researchers published a study in the journal Science Advances that pushed the timeline for upright walking back further than almost anyone expected. They examined the remains of Sahelanthropus tchadensis, a species that lived around 7 million years ago, one of the very earliest creatures anyone considers a potential human ancestor, and found something small but decisive, a tiny bony ridge on the thigh bone called a femoral tubercle. That ridge is the attachment point for one of the strongest ligaments in the human body, the one that lets you lock your hip and stand upright without your muscles burning out from the effort. Chimpanzees don't have it. Sahelanthropus did. That single feature, alongside several others, the team analyzed using detailed 3D imaging, suggests this creature was already walking on 2 legs 7 million years ago. Millions of years before anything resembling a stone tool existed, long before any hand needed freeing for anything at all. For decades, some scientists doubted Sahelanthropus could walk upright at all, arguing the skull alone wasn't enough evidence, and that a single partial thigh bone was too little to build a whole conclusion on. This new anatomical detail, hidden in a single small ridge of bone that nobody had studied this closely before, is what finally tipped the argument, because it matched a pattern seen only in confirmed bipedal hominins and in nothing else. Standing up came first. The tools came later, sometimes millions of years later. The story wasn't hands looking for a job. It was legs looking for a better way to move. That's not a tool user's leg, that's a walker's leg. So if it wasn't about tools, what was actually driving this? A separate study, published in Nature in 2025 by a team led by Terence Capellini at Harvard, went looking inside the human pelvis itself for an answer and found something genuinely strange. The human hip bone, the ilium, is shaped completely differently from the same bone in every other primate, including our closest relatives. The researchers tracked exactly how that shape forms, starting before birth, using embryonic tissue samples, and identified 2 separate structural shifts happening at different points in development. First, the cartilage growth plate that shapes the bone rotates into an orientation found nowhere else in the animal kingdom. Then the bone hardens in a pattern that's also completely unique to us. 2 changes, stacked on top of each other, had to happen just to build a pelvis capable of efficient upright walking. The team compared the pattern against other primates, and even mice, and found nothing else in the animal kingdom that develops its hip bone quite this way, which suggests this wasn't a small tweak evolution stumbled into easily. It was a genuinely rare rebuild. Here's the complication nobody mentions in the tools and tall grass version of the story. That same pelvis also has to let a baby's head through during birth. Human babies are born with unusually large heads, relative to the size of the birth canal, because human brains are unusually large compared to body size, even at birth, even before most of that brain growth has actually happened. A pelvis narrow enough for efficient 2-legged walking, and wide enough for a big-brained baby to pass through safely, are 2 competing engineering problems, solved inside the exact same bone by the exact same set of developmental instructions. Researchers call this tension the obstetric dilemma, and it's a major reason human childbirth is dramatically more dangerous and difficult than it is for almost any other primate on Earth, including our closest living relatives, who give birth in a fraction of the time with a fraction of the risk. Standing upright didn't just free your hands. It rebuilt your entire skeleton around a trade-off your body is still negotiating every single day. One bone doing two jobs that pull in opposite directions. That trade-off never stayed safely in the past, either. Lower back pain, the kind that sends more people to doctors worldwide than almost any other single complaint, exists largely because your spine is stacked in a tight S-curve directly over a narrow, twisted pelvis, a structure built for efficient walking, not for sitting in a chair for 8 hours or carrying a heavy bag on one shoulder for years at a time. Difficult, prolonged, occasionally dangerous childbirth exists because of that same narrow pelvis, doing double duty as both a walking machine and a birth canal, a compromise no other primate's body has to make quite so severely. You're not imagining that your back hurts more than a chimpanzee's does, or that human labor looks nothing like what you'd see in a nature documentary about any other ape giving birth, calmly, briefly, and usually alone. Roughly 8 out of 10 adults will deal with serious lower back pain at some point in their life, and human childbirth remains one of the few births in the entire animal kingdom where a mother regularly needs another person's help just to survive it. You're living inside a compromise that's 7 million years old and was never fully resolved, only ever good enough to keep working, generation after generation, right up to you. So stand up again. Feel your weight settle over your hips, your spine curve into that same tight S, your 200 muscles quietly doing their balancing act without you noticing any of it. That entire system, the one letting you stand here effortlessly right now, is the exact same system responsible for every hour of labor pain a human mother has ever endured, and for every twinge in your lower back after a long day spent sitting down. Walking upright wasn't the reward for getting smart. It came first, 7 million years before the first tool, and it forced your entire skeleton into a trade-off between moving efficiently and being born safely, a trade-off your body is still quietly paying the price for every single day. You didn't just inherit the ability to walk, you inherited the bill for it.